Hi, it's Monday, June 1st, 2020. My name is Noah Seeley, and welcome to my channel. So today I have two solutions for you guys from LeetCode that I did earlier today, and another one that I did a few weeks ago. So today I've learned a lot from other entries and programmers who wrote articles on certain websites. I'll reference the sources of codes and articles from those people down below when it's relevant. With that being said, let's move on to the video. So my first question that I did on LeetCode today was an easy difficulty question, and as you can see by the code, it's a pretty simple implementation. Logically, it's pretty easy to figure out. Basically, how you can see this revx variable, we're just kind of keeping it as a temporary variable throughout the code, which will be used to flip the inputted integer around, so then we can check the two and see if they're equal to each other. If they're equal, of course, it means that they're palindrome, and the function will return true, and if not, it will return false. And as you can see right here is the little reverse number algorithm that we have here. This was the only real tricky line that I found. It's called program to check the number is palindrome or not. And it was made by Rishabh Prabhu. So thank you to him. I just wanted to cite him here. He was responsible for these two little lines of code, and I kind of based my algorithm around his. So by multiplying this temporary variable by 10, we kind of move its significance up. So we're moving each number up, and then we're adding on top of it the last digit that can be found in the num, and to find that, we use the modular operator. And then of course to reset the num we have to divide it by 10 so we can get access to that next digit. So basically this implementation uses a lot of manipulation so that we can kind of find each digit located in the number. And yeah, there you have it. So that's how we solve the first question. And moving on to the next question is simply called pow bracket xn bracket. You can kind of see this in a lot of simple functions that you'll find in a lot of languages. Basically, the goal of this, as you can see here, is we calculate x raised to the power n. So at first I thought this would be a pretty easy implementation. I just kind of wrote an iterative approach that was of big O of n time complexity. And as it turned out, in the test cases, it solved about, I'd say 90% of the test cases, but for some it was just too slow. So I went online and I did a little research, and I found this great article on how to find the solution to this using an algorithm that's of big O to the log n time complexity. The article was made by Udit Gupta, so thanks to them for the help. And the basis of the algorithm is that we're going to be checking the binary sequence of each n that's passed through as input. And we're going to be checking which bit is set to 1 on each of the binary bits of the n number that we're given. So if it's set to 1, that means that it is a number which we need to incorporate into our total. So basically say that we have 1110, which is equal to 14. What we would do is see that the last 3 significant bits are 1, 1, and 1, which represents, the 0 is skipped. We have the 2. We have the 4, and we have the 8. So we would add all of those together, and that's what we're basically raising our exponent to. So using this algorithm, we're actually able to skip a lot of the steps in an iterative process. So then, of course, we have to do a right bit shift so that we can kind of set up the next bit in that binary sequence so that we can process it. And we basically process it until there are no bits left to process. Now, one interesting thing I learned today is this AND operator, which kind of represents the AND circuit gate. So if we're doing N, which is the bit that we're selecting, AND operator 1, it basically means that both have to be 1 for it to be equal to 1. So that's kind of how we validate that using Python to see if the bit that we're looking at is a 1. So this little algorithm only so far covers the positive cases. To basically compensate for negative cases, I've just written a little line of code here, and it says that if it is negative, we will set it to positive basically, and that this do variable will equal true. While that do variable equals true, we basically put 1 over the total that we find. And we do this because negative exponents are just 1 over their positive counterpart. So yeah, that solves this question. I hope you guys got that, and we're going to move on to the last LeetCode question that I was looking at that I wanted to include in this video. So this one's a medium difficulty one, and it's called longest substring without repeating characters. Basically, given a string, you have to find the longest substring without any repeating characters. So I remember this one taking a bit longer than usual just because I didn't really use any articles or other resources to learn how to do a more optimal solution. So I think I would recommend recommend that you do use articles to learn optimal solutions, or even if you're at a point where you think you've solved it but you know that there's a better solution. Even though there's less originality in this little part of the code, I think you're learning a lot more so that you can contribute more originality to future solutions. That's just part of the learning process. I think it's okay that I'm doing this as long as I continue to cite all of my work and I'm just very transparent with whose work I'm looking at and which ones I'm kind of taking as a reference while I'm showing you guys these solutions. Anyway, back to the question, I was able to write this little algorithm for it and it was able to pass all of the test cases. So basically as a tracker for the substring, we're just using the length of the substring and this will be used kind of throughout to continuously check whether we're at our longest length of substring so far. How kind of the main part of the algorithm works is that we're going to be using this find Python method. What that basically does is it's going to tell us if a character within the string is within the substring that we kind of have selected so far. If it isn't so far in that substring, we're basically going to put that character in the substring. So say it's BC and we find an A as the selected one, that would just be append or concatenated back on. If it isn't though, we're basically going to reset the substring and we're going to reset it to the point after the character that's making the repeat happen. So basically if we have BAC and we have a B, we're going to drop that B that we had originally and it's going to turn to ACB. So we're going to iterate that throughout the whole length of the string, and upon every iteration, we're just going to be constantly checking if the length of this substring is larger than the longest, and if it is, it'll become the new longest. And then at the end, we just return the longest, and yeah, that's it. That's the question. So yeah, guys, this concludes my LeetCode questions for today. I think tomorrow I'm going to be reviewing and kind of discussing a machine learning article that I found is really interesting. That's how this channel is going to go. I'm just going to keep on bouncing back from LeetCode to machine learning articles day by day, just to add some variety to the learning. Once again, you can find all the references that I've used down below. Thanks for watching. See you tomorrow.